Alright, so what we have here is a lesson on solving systems of equations by substitution. And first what we need to do is establish that substitution, we're just going to substitute one of the equations in for the other. Like this one here in the first example, the first equation is solved for y. Since it's solved for y, we can take the 3x and substitute it in place of the y. So when we do that, we're just replacing the y with 3x. So since 3x is equal to y, we can replace it like we've done, and then from there we're just solving an equation. So 2x plus 12y, or 12x, sorry, is equal to 28. So then 14x is equal to 28. We combine like terms. Then we're going to divide by 14. We get x is equal to 2. And once we've established that x is equal to 2, we go back up and we substitute into one of the original equations. I'll substitute into the first equation, and we're going to replace x with 2. So then y is equal to 6. So the order pair solution for this particular problem would be 2, 6. Right? We could check that by graphing the two equations and making sure that they intersect at that order pair 2, 6. Alright, the next problem we have, in this problem, we don't have one of the variables solved. So when we look at this particular problem, what we need to look at it with is a perspective of what variable might be the easiest one to solve for. And if we look in the second equation, you see the y has a coefficient of 1. So I'm actually going to take the second equation and solve it for y. Alright, so in order to solve that second equation for y, subtract 3x from both sides. That's going to give me y equals negative 3x minus 7. So now that I've got it solved for y, I'm going to take that negative 3x plus 7 and substitute it in for the y. So we'd have negative 2x plus 3, and instead of y, we have negative 3x minus 7, and it equals 12. And again, once we get to that point, we're just solving the equation. So we would distribute first, get negative 9x minus 21 equals 12. And we're going to combine like terms here, since they're on the same side of the equal sign. So that would be negative 11x minus 21 equals 12. Go ahead and add 21 to both sides. We get negative 11x is equal to 33. And then when we divide by negative 11, we're going to end up with x is equal to negative 3. Alright, and again, we're going to substitute back into one of the equations. And it doesn't matter which one, we should get the same answer regardless. I'm actually going to, since I've got this equation right here solved for y, I'm actually going to go ahead and substitute in there. So that would be y equals 9 minus 7, so y would be 2. So the order pair solution for example 2 would be negative 3, positive 2. Alright, in the third example, this one is actually already solved, so that's going to make it a little bit easier. We're going to take our negative 3x and, we didn't want to do that, negative 3x. We're going to substitute it in place of the y. So that would be 6x plus 2 times negative 3x. So that gives us 6x plus negative 6x is equal to 10. And when we go to combine like terms, that gives us 0 equals 10. Okay, so what's happened is our variable has canceled out. We no longer have a variable. So at this point, is this statement true or false? This is a false statement, and anytime it's a false statement, we're going to have no solution. Alright, and the next example, I'm going to take that negative 3x plus 5, and since it's solved for y, we're going to substitute it in for the y. So all we do is replace the y with negative 3x plus 5. Alright, this time for this particular problem, we're going to go ahead and distribute the 2. We end up with 6x plus negative 6x plus 10 equals 10. Alright, so then we're going to combine like terms. And that gives us, those are going to cancel out because that's 0x, so then 10 equals 10. And this time, this gives us a true statement. And anytime it's true, it's going to be infinitely many solutions. Alright, so there's a lesson on solving systems by using the substitution method.